Welcome year 11 to our first online video. So the topic we're looking at today is unit vectors, and the symbol we're going to use for unit vectors is a letter with a hat on top of it. So first we'll start by looking at the definition of unit vector. So a unit vector is a vector that goes in a particular direction and has a magnitude of 1. Now magnitude means length. So it's a vector that has a length of 1, and to find a unit vector is very simple. We find a unit vector, divide the given vector by its magnitude, and the formula for finding unit vector is given in the little bubble. So a hat is the unit vector, equals vector a divided by the magnitude of a, which is the length of a. Now let's have a look at a few examples. Vector a is 3i plus 4j. Find a unit vector in the direction of a. So what we want basically is a vector that goes in the direction of 3i plus 4j, but whose length is 1. So we're just going to apply the formula that we saw above. 3i plus 4j is a vector. We divide it by its magnitude, its length, and which is 3 squared plus 4 squared under square root, which is 9 plus 16, and that will give us square root of 25, which is 5. Therefore the unit vector will be 3i plus 4j over 5, which can split into two different components, I and j, separately. Example 2, we're given two different vectors. Vector a is I plus 2j, and vector b is 3i take 4j. The question is to find a unit vector parallel to a plus b. So before finding the unit vector, first we have to find a plus b. And remember, one of the easiest way to find this is to write vector a and b in column vector form. So vector a is I plus 2j, which we can write as 1, 2. Vector b is 3i take 4j, which we can write as 3, negative 4. By adding them, we add the first number in each bracket, which is 1 plus 3 gives us 4, and then 2 take 4 is negative 2. So therefore a plus b is 4, negative 2. And then to find a unit vector parallel to that a plus b will be 4i plus 2j divided by the magnitude of 4i plus 2j, which is 4 squared plus negative 2 squared, and hence we get the final answer as 4i take 2j divided by square root of 20. Next example, we're given that vector p is 3i take 4j, vector q is I plus j, and vector r is 2i plus 4j. And first question, we have to find a vector in the direction of r having the same length as vector p. So there's two things that we have to bear in mind here. We need a vector having the same length as p. So first we'll find how long is p. So we find the magnitude of p, which is square root 3 squared plus negative 4 squared, which gives us 5. So p has a length of 5. So we want a vector in the direction of r which has a length of 5. So what we need to find is you need to find a unit vector r. So if the length of unit vector r is 1, and then we'll multiply that by 5, means it should have a length of 5. So finding unit vector r is 2i plus 4j. So we divide it by its magnitude. We get 2i plus 4j over square root of 20, and the final answer will be we need to multiply that unit vector by 5, and this is our final answer. Next question, a unit vector parallel to the resultant of p, q, and r. Now note, resultant of p, q, and r is p plus q plus r. You add them all, like in the scale diagram we saw last time. So we add all the three vectors, we'll get 6 and 1. So the required unit vector will be 6i plus j divided by square root of 6 squared plus 1 squared, which is square root of 37. Now you should be able to try exercise 4B. Thank you.